So friends, in this session we will solve some problems in saturated aliphatic hydrocarbon. So what volume of methane at NTP is formed from 16.4 gram of sodium acetate by fusion with soda lime? So first you write the reaction. Reaction is CH3COO. This is the sodium acetate and it is reacting with the sodium hydroxide in presence of calcium. This is called soda lime. So what will happen? So on heating, this will give you CH4 plus sodium carbonate. So this is our reactions. Now they're asking, this is your how much? 16.4 gram. So how much methane is produced at STP? So to find this volume, so we have to first calculate this one. What is the molar mass of sodium acetate? So if you calculate, so you will get 82 gram. So molar mass of sodium acetate is 82 gram. So 82 gram is giving what? 1 mole of methane gas, which is nothing but the 22.4 liter. So 16.4 gram will be how much? So definitely it will be 22.4 liter divided by 82 multiplied by 16.4. So if you solve it, so you will get answer 4.48. So if a rocket was fueled with kerosene and liquid oxygen, what mass of oxygen would be required for every liter of oxygen? Assume kerosene to have a average composition C14H30 and density of kerosene is 0.764 gram per ml. So first you write the equation C14H30. So it will react with the oxygen to give CO2 plus water. So balance it becomes 40, this becomes 50 and this is 43 by 2. And mass, if you calculate, this is 198 gram and mass of this is nothing but the 688 gram. Now they are asking 1 liter of oxygen will give you how much oxygen? How much gram of oxygen? So first you convert this kerosene into the volume. So volume is equal to mass by density of kerosene. Mass is given 198 and kerosene density is given 0.764. So for oxygen, this is the total volume of C14H30. So this is giving 688 gram. 688 gram of oxygen. So this is gram per ml. So you have to multiply by 100,000 to make it liter. So this will be your, for 1 liter we require 688 divided by 198 into 0.764 and then again multiplied by 1000 to convert into liter. So you will get answer 2654.7 gram of oxygen. Calculate the heat of combustion of methane at room temperature from the given bond energy. So CH given this much kilocalorie per mole, oxygen given, OH given and CH given. So right here CH4 plus oxygen will give you CO2 plus 2 molecules of water. So balance it. We have to find the delta H will be how much. So delta H is nothing but the bond energy of the reactant minus bond energy of the product. So bond energy means you can see how much is there. 4 into energy of 4 into CH plus we can write 2 into O bond energy and this is give you minus, this will be your 2 into energy of CO bond and plus 4 into energy of OH bond. So just put the value 4 into 98.7 plus 2 into 119.1 bracket close minus this will be your 2 into 192 and again this will be your plus 4 into 110 plus 6. So if you solve it, on solving you will get 193.4 kilocalorie per mole. So this is our answer. So which alkane having a molecular mass of 86 will form only 2 monobromo alkanes? So right here let alkane is CnH2n plus 2. So we'll take 12n plus 2n plus 2. So this is equal to 86. So on solving you will get n equal to 6. So alkane is C6H14. So this is our hexane molecule. Now next is that how many they will form the two monobromo alkanes? We will find the isomers of this one. So what is the isomers? So isomers will be, you can see hexane. First is the 6 carbon, then we will take the 5 carbon chain. So 5 carbon will be 1 2 3 4 5 carbon. So one will be over here, one will be your center. So this is the 5 carbon chain. And if you take the 4 carbon, so 4 carbon will be 1 2 3. So one will be your this side and second will be your this one. So there are 1 2 3 5 isomers are there. So who can give the two different mono bromo alkanes? So if you can see, so it will be answers this one. So this can give only two mono bromo alkanes, because in this case 1 2 3, so here will be 3 bromine will be there. In this case 1 2 3, so there will be 3 and 4. So there will be your 4 Br. In this case 1 2 3 4 5, so 5 Br, and the 1 2 3 4 5, 1 2 3 only. In this case 1 2 3. Here many are there. If you take the 2, many are there. So only this is the possible answer. So N-butane is produced by monobromination of ethane followed by Wurtz reaction. Calculate the volume of ethane at NTP required to produce 55 gram of N-butane if the bromination takes place with 90% yield and the Wurtz reaction is 85% yield. So write first this one reactions. Bromination of ethane, so C2H6 plus Br2, so it will give you C2H5 Br. And next is here, this will undergo again with sodium, so we can write C2H5 Br and plus sodium with Wurtz reaction, so this will give you C4H10. This will undergo, it will double, and here will be NaBr. So balance it, so it will be your 2, this will be your 2, and this is a 2, so it is balanced equation. So now we can see, so this is your molar 30 gram. If you calculate, so this is giving how many gram of ethyl bromide? So this is your 109 gram. So 30 gram is giving 109 gram. So this is nothing but the 2 into 109 gram. So this will give you how much butane? 58 gram. Now we have data. Data is that, so if you take for 58 gram of butane, it is giving how many? 2 into 109 gram of ethyl bromide, because you have to go reverse way. So for 55 gram as per the question, so 55 gram of butane, so we require how much? 2 into 109 divided by 58 into 55. So this is the total gram of ethyl bromide. But the yield is how much? So yield is, we can see it is 85%. 85%. So 100, if you take the 100 gram, so if you take the 100 gram of this one ethyl bromide, then you are getting 85. Okay. So for 85 gram of ethyl bromide we require 100 gram. So if you take this much, 2 into 109 divided by 58 into 55, so we require how much? So 800 by 85 multiplied by 2 into 109 divided by 58 into 55. So this will give you how much? 243.2 gram. So this much gram of ethyl bromide will be required. And how much they are giving ethane? So we'll calculate how much ethane is produced. So from here we can see, if you take 109 gram, you can calculate 100 gram ethyl bromide. So we require how much? 30 gram of ethane. So for 243, so for this much 0.2 gram we require how much? So it will be your 30 upon 109 into 243.2. So you will get answer 66.93 gram. Now actual ethane is how much? So yield is again given there 90%. You see the question, so yield is 90%. Okay, so 90% means what? If you take 90 gram of ethane, so we require how much? 100. So if you take 66.93, so we require 100 divided by 90 into 66.93. So you will get 74.37 gram. So this is the actual ethane required. Now what is the volume? So volume will be 74.37 divided by 30 into, so this becomes your moles, and multiplied by 22.4 liters. So you will get answer 55.5 liter. So this is our actual answer. Calculate the delta H for the two propagation steps in the reaction of methane with Cl2. The bond energy of CH3H, CH3Cl, HCl and CCl, ClCl are given this much. So first step will be what? Step 1 will be your breaking off. We write breaking off CH3 hydrogen bond and plus forming of HCl bond. So this is our first step. So if you solve it, it becomes your 105 plus minus 103. So how much is there? So you will get answer 2 kilocalorie per mole. Now step 2. So step 2 will be breaking of Cl bond, and second is forming of CH3 Cl bond. This is second step. So you will get answer 58 plus second is your 85. So you will get answer minus 27 kilocalorie per mole. So this is the two propagation step for this reaction. The relative reactivity of primary, secondary and tertiary hydrogens to chlorination is 1:3.8 and 1:5 respectively. So calculate the percentage of isomers formed during monochlorination of 2-methyl butane. So we have 2-methyl butane. So this is the 2-methyl butane, second carbon. And if you give chlorine, so it will form different type of products. So let us see which are the products are there. So it will give you Cl2. This will give you, can see this product. So this is the Cl. You will get this product. This part is Cl. Next you will get this product. So this is the Cl, and you will get product. So this part is the Cl. This will be as it is. So we have A, and this is your B, and this is your C and D. Now we have to find out what is the relative proportion of these 4 products. So we have 4 isomers, 1, 2, 3 and 4. So we'll take one by one. So in case of A, what is the percentage yield? So we can see we have in case of A, we have 3 primary hydrogen, 1, 2, 3, 6 primary hydrogens are there. One is this side and one is this side. So in this case, what happens is Cl is this side. So for this one, what is the yield of this Cl? So we will take 3 equivalent hydrogen. So multiply 3, and the reactivity of this hydrogen is given 1. So this will be 1, and you have to divide. So this will be your 3. And similarly for B, if you take, so there are secondary carbon. So it will as 2 into 3.8. So this will be your 7.6. Now third is this is a tertiary carbon. So for this one, reactivity is 1 into 5, that is 5.0. And for D, we can see this is the primary carbon. So there are 2 carbons. There is possibility. This was possibility. There are 2 possibilities. So we'll write 6 into 1. So we'll get 6. So if you add, it will becomes your almost 21.6 on addition of all this one. So we'll find the percentage of each one reactivity. So this will be your 3 upon 21.6 multiplied by 100. So you will get answer 11 point, sorry, not 11, it will be 13.9%. In this case, it will be 7.6 divided by 21.6 multiplied by 100. So you will get answer 35.2%. And for this one, so 5 divided by 21.6 multiplied by percentage. So you will get answer 23.1%. This is 1%. And in this case, it will be 6 divided by 21.6 multiplied by 100, and you will get percentage 27.8. So this is the percentage of respective primary, secondary, and tertiary haloalkane, that is a 2-methyl-butane when reacting with the chlorine. This is the percentage of isomer formed during the monochlorination of 2-methyl-butane. Now we see in the next question, the relative reactivity of primary, secondary, and tertiary hydrogen to bromination is 1:82 is to 1600. So this is the reactivity of primary, secondary, and tertiary hydrogen. Calculate the relative amount of each product on monobromination of isobutane. So isobutane is compound like this one. So this is the isobutane, and if you do bromination, so one bromination, so you will get 2 products. So these products are basically, so one will product this one bromine, and second product you will get this one product. So this is the bromine. So this is the A and this is the B. So now we have to find the what is their percentage. So now we can see, so bromine can be attached over here and over here and over here. There are 3 places. So for these places, percentage of A will be your how much? 9 into 1. So this is the reactivity of primary is 1. You can see this is reactivity 1, so 9 to 1. So this will be your 9. Next, the second case, so it is attached with the second carbon, third carbon, tertiary carbon, and their reactivity is 1600. So it will be your 1600 into 1. So you will get 1600. So if you add it, it becomes 1609. So this is your total, this one percentage, this one. So for this one, what is the percentage? So 9 divided by 1609 into your 100. So if you solve it, so on solving you will get 0.6%. This is value. Similarly, if you solve this one, 1600 divided by 1609 into 100, so you will get 99.44% value. So this is the percentage of this one relative amount of the each product on monobromination of isobutane. So we have seen this and this, they are the different percentage.